Welcome to Manifested Publishers. My name is Mr. Bernard Mariga. I'll be teaching you Advanced Management Accounting. And today I want us to use the decision tree approach to determine your expected value of perfect information. Your expected value of perfect information. Your expected value of perfect information, remember, it is given by expected monetary value with perfect information minus expected monetary value without perfect information. Without perfect information. But remember, the other name of expected monetary value without perfect information is simply EMV. Now we said it is a summation of your payoffs and your prior probabilities. And your prior probabilities. Then you select the the maximum. You select the the maximum. So using a decision tree, remember, number one, you must have a your decision alternative, which we said is denoted as a as a rectangle. You must have your states of nature, which we said, how do you represent that? Using a sphere or a circle. You must have your flow of information, which is a line. Flow of information, which is a line. And lastly, you will have your payoffs. You will have your payoffs. Your payoffs that way. And I want us to go to a question on August 2024. Question 4b. Question 4b. Question 4b. Part 2 of that question. 4b, part 2 of that question. Where they're saying, determine the expected value of perfect information. The expected value of perfect information. But the first part B of that question, they are saying, the finance director of Lengo Training Institute is considering a proposal by the board of directors to launch a new course nationwide. The potential enrollment of the course is classified as either high, medium, or low. The net present value under each of the three conditions is estimated to be 50, 10, and negative 20 million, respectively. The marketing director of the institute estimates that there is 0.4 probability that the enrollment will be high, 0.25 probability that it will be medium, and 0.35 that it will be low. The objective of the institute is to maximize the expected net present value. And they want you to determine your expected value of perfect information, but we want to use a decision tree approach. So you're going to have that as your alternative. Your decision is either you're going to launch a new product or not. So you either do what? You do not launch a new product or a new course. In fact, it is a new course, not a new product. A new course, or you do what? Launch it. Or you launch it. When you launch it, they're saying that you have either you're going to have high enrollment, medium, or low, and they have given us what? Probabilities for each. So when you're given probabilities, it means those are states of nature, because you're using what decision-making criteria? Conditions of risk, or you must have what? Prior probabilities. Conditions of risk, you'll be given prior probabilities. So let me represent this in a better way. You will understand. And here you'll have your states of nature. So you have high, medium, and low. High, medium, and low. probability of 0.4, 0.25, and lastly how much? 0.35. Then we have our states of nature given by probabilities. Then we need to determine our payoffs, and the payoffs of each, when under the condition that was 50 million. So I'll have my values in millions of shillings. That was 10 million. And lastly, this is a loss of 20 million. Okay. Having presented that, then let's now determine our what? Expected monetary value with perfect information. So your expected monetary value with perfect what? Information. Your expected monetary value with perfect information. Let me compute it here. Expected monetary value with perfect information. You're going to say it will be under high, the payoff is 50 million with a probability of 0.4 plus launching, your payoff is 10 million with a probability of what? 0.25, but low, and you have, and with low enrollment, your loss is how much? 20 million. But if you had positive, or if you are sure that low will give you a what? A negative, you will not have accepted to launch the product and to generate what? A loss of negative 20 million. What instead you would have done, you would have taken all the necessary measures such that you don't get a what? A loss. The only thing you can get is a what? You may not make a profit, but do not make a what? A loss. So therefore, you're going to make a what? Or you're going to not make any profit and loss, so you're going to have a what? Zero cash flows. So here instead of 20, you're going to have what? 0 times what? 0.35. 0.35. And then we calculate that. Remember, we've said instead of a loss, you're going to ensure you don't, at least you cover your costs. At least you cover your cost from your payoffs. 10 times 0.25 plus 0. So there, if you had perfect information, your cash flows should be worth how much? 22.5 million, or your payoffs should be 22.5 million. Let's now get the expected monetary value without perfect information. Without perfect information, your cash flows will be 50 million by what? 0.4 plus 10.3, 10 times 0.25 plus, without perfect information, you're going to make a loss of 20 with a probability of 0.35. 20 with a probability of 0.35. So this is the normal EMV. 15.5 million. Therefore, your value of perfect or your expected monetary value, which is the value of perfect information, monetary value of perfect information, you simply now get the difference. You simply now get the what? The difference. So this should be 7 million. That should be 7 million. All right. And that is how you determine the expected value of perfect information. Expected value of perfect information, which is here. Expected value of perfect what? Information, which using which decision making criteria? Using your decision tree. Using your decision tree. All right. Your assignment, I'll give you an assignment. Please attempt the same August 2024, question 4B, 4C now. Question 4C. Can attempt that question for what? For practice purposes. All right. And we've come to the end of our decision-making environments. From me and on behalf of the school, goodbye and God bless you.